For number 10, it says solve the system of equations using the elimination method. And so I have to decide, do I want to cancel x's or do I want to cancel the y's? And in this case, I would cancel my y's. I already have a negative 2y. So I have to figure out how to make this a positive 2. And this is 1. So what do I multiply that by to make that a 2? And it would be 2. So I would say negative 6x and then 2y and then negative 14. Bring down the second equation. So then I need to cancel or eliminate my 2's. If I combine, which means subtract in this case because a negative and a positive make a negative 1x. Here, negative 14 and 12 means I'm subtracting, so negative 2. To get x by itself, I divide by the negative 1, and x is 2. To get the y, I need to plug it back into one of these equations. So even though I have smaller numbers at the top, I have more negatives up there. So I'm going to use the bottom equation. Okay, so I'm going to highlight that just so we know that step 2, I am using the 5x minus 2y. So 5 times 2 minus 2y equals 12. So if I multiply, we get 10. Then I would subtract the 10 from both sides. I'm going to rewrite down here, so 2y equals 2. Divide by 2. Y is 1. In number 11 and 12, it's just asking, is that point the solution to this system? And so since we don't have a graph, we can't graph it, so we could label this x and y and plug it into the equation. So negative 5 times 3 plus y is 1. Does that equal 19? So negative 15 plus 1, and that equals negative 14. So that does not equal 19. So the answer is no. It has to plug in to both equations and equal the other side evenly. So here we've got x and y again. So for 0 is my y. Then negative 3 plus 3, which is 0. So that one worked. And then for the y equals 2x minus 6, I've got 0 equals 2 times 3 minus 6. If I multiply, I get 6 minus 6, and that equals 0. So that means that yes, 3, 0 is a solution to the system. It worked in both equations. Okay. For 13 and 14, these go together. So Jane sold 400 tickets for the school play. Student tickets cost $2, and adult tickets cost $5. Jane's sales totaled $1,700. So we discussed in class that we would do our tickets first. So this is my little ticket. I have student tickets, adult tickets, and the total amount of tickets, which is 400. Okay, so we're looking for S plus A equals 400. So it looks like we have B, C, or D. Okay. Then our student tickets cost $2. The adult tickets cost $5. And Jane's total amount of money was $1,700. So now I'm looking for 2S plus 5A. So that's not it. Nope. Yes. Okay. So now I know I matched it up with D. Okay, so this was my money. That was my tickets. Matched to D. Then down here for 14, it says solve the system in number 13 to determine how many tickets, how many student tickets and how many adult tickets Jane sold. So if I look at this system, what do I multiply this equation by to eliminate my S's? So the opposite of 2 is negative 2. So I need to multiply this by negative 2. So if I do that, I have negative 2s, negative 2a, and negative 800. The second equation I just rewrite. And I do exactly the elimination method. So in this case, I can eliminate my S's. If I combine my A's, I get 3A. And then if I subtract 1,700 minus 800, we get 900. And if we divide by 3, we get 300 adults. So A is adults, so we know that we have 300 adult tickets sold. Now, we also know, according to the story problem, there were a total of 400 tickets sold. So if we have 400 tickets sold, and we know that 300 of them were adults, we subtract those to get the student. So that would be 100.